Today we are going to see multiples and factors. So what is multiples and what is factor? We'll see one by one. So how can you write 6 as a product of two numbers? Can we write 6 as a product of two numbers? Yes. You can write 1 into 6. The same 6 can be written as 2 into 3, and the same 6 can be written as 3 into 2. Another way of writing 6 as 6 into 1. So 6 can be written as the product of two numbers. Okay, so you can see that. You can write 6 as a product of two numbers. So any natural number other than 1 can be written as a product of two or more numbers. For example, you can check with you can start with 2 also. 2 can be written as 1 into 2 and 2 into 1. So 3 can be written as 1 into 3 and 3 into 1. So 2 into 1, 3 into 1, and 4 can be written as 1 into 4, 2 into 2, and 4 into 1. So any natural number can be written as a product of two numbers. Okay, this is enough right now. So I will teach you how can we find the divisors of any particular number. So we'll see what is the divisor now. Let's take one number 6. I'm going to divide it by 1. So how many ones are there in 6? So 6 ones are there in 6. So 6 ones are 6, remainder 0. So I'm going to divide again it by 2. This time I'm trying with 2. So 3 2s are 6, remainder 0. So the same 6 I'm going to divide by 3 now. So 2 3s are 6, remainder 0. And same 6 I'm going to divide with 4. Okay. So 1 4s are 4, remainder 2. Okay. So 6 again by 5. So 1 5s are 5, remainder 1. And again with 6. Okay. So 1 6s are 6, remainder 0. Can you see the remainder? Some division we have remainder 0. Okay, but some divisor we have remainder other than 0. So what are the divisor of 6? The divisor of 6 is 1, 2, 3, 6, because these numbers, when we divide with 6, we get the remainder 0. But do we get the remainder 0 here? No. So it is not a divisor. So what are the divisors of 6? So what are the divisors of 6? Divisor of 6. So divisors of 6 are 1, 2, 3 and 6. Okay. So these are the divisors. You can check even with any other number. You can try with your own number. So you can even say 4. What are the divisors of 4? How can we find the divisors of 4? You start to divide from 1. Okay. So you start to divide by 1. So 4 I am going to divide by 1, 2, 3 and 4. So how many 4s are there? How many 1s are there in 4? You have 4 1s are there in 4. So remainder 0. 2 2s are there in 4. So remainder 0. 1 3s are there in 4s, so remainder 1 here. Okay, and 1 4s are there, so remainder 0. Okay, so here you can see that what are the divisors of 4 now. So the divisors of 4 are, how can you say, so 1 2 4. so the divisors of 4 are 1 2 and 4. Okay, so we know what is the divisor. We know how to find the divisors of a particular number. What are the factors? So I'm going to write the so you can see that the divisors of 6 are 1 2 3 6, and divisors of 4 are 1 2 4. Here you can see that if you take another number also, let's take another number. Okay, divisors of 18, I'm going to write divisors of, let's take 8. So what are the divisors of 8? 1 2 3 won't come, so 4 and 8. Okay, okay, do you see anything common here? Do you see anything common here in divisors of 6, divisors of 4 and divisors of 8? You can see that in all the numbers divisors you have 1. Do you have 1? You have 1 in all the divisors. Okay, all the numbers divisors you have 1, and you have the same number. If you have a 6, you will be having 6. So 6 4 8. So the divisor will always have 1 and the number itself, okay. So we know what is a divisor. We will see what are the factors. So how can we find the factors? So what is a factor? Okay, so what is a factor? So factors are if you don't include the one this one and the number itself, then you will have factors. So factors, okay, it's simple, it's easy one. Okay, factors. So I'm going to write the factors of 6. So what are the factors of 6? So how will you find the factors of 6? It's easy. In divisor you remove the 1 and the number itself. So 2 3 are factors of 6. So what are the factors of 4? 4, you remove 1 and the number itself, you will be having 2. So what are the factors of 8? Factors of 8 are, you have to remove the 1 and 8, so 2 comma 4 you will be having. Okay, so this is factor. So you can easily find the factors of a particular number. Okay, we know what is a divisor, we know what is a factor. So we will move to the next step. So as you know, so what is the divisor of 1? Divisor of 1 will be 1 only, not any other number. What about the divisor of 2? The divisor of 2 is 1 comma 2. The divisor of 3 will be 1 comma 3. The divisor of 4 are 1 comma 2 comma 4. And what are the divisor of 5? 5 is 1 comma 5. What are the divisor of 6? You have 1, because 1 divides 6 without any remainder. Okay, so 2 also divisor, and 3 also divisor, and the same number 6 also a divisor. So you can keep on writing the divisors of any number, but you know what is the prime number? What is the prime number? From this we can know what is the prime numbers. Prime numbers are numbers that have only 2 divisors. Okay, so can we say 2 is a prime number? Yes, it has two divisors. Okay, so let me use another color. Okay, let me use another color. So 2 is a prime number because it has a two divisors. 3 also a the prime number because it has only two divisors. 5 also is a prime number. So what is a prime number? It has only two divisors. So two divisors. So what if it has more than two divisors? Those numbers are called composite numbers. So 4 and 6 are composite numbers. Composite number. So these numbers are composite numbers. You know already that this number is a prime numbers. Okay, so what about 1? Does it have two divisors? No. Does it have more than two divisors? No. Then 1 is called neither a prime number nor a composite number. It's not a prime number and it's not a composite number also. So this number is neither a prime nor a composite number. Neither a prime nor a composite number. So I already told you in the beginning, we can write any number as a product of natural number. Any natural number other than 1 can be written as a product of any two numbers. Okay, so can we write any numbers as a product of prime numbers? So that is called prime factorization. So we are going to learn prime factorization. So what is a prime factorization? Any number can be written as a product of prime numbers. We know what is a prime number. No, prime number is circled here. So here you can see that 2 is a prime number. So 2 is a prime number, 3 is a prime number, 5 is a prime number, and you will know that 7 also prime number, and it goes on. Okay, so how can we find prime factorization of a particular number? We know what is a prime factorization. Prime factorization is the method of expressing a number as a product of prime numbers. Okay, so we know what is prime number. How can you represent a number as a product of prime numbers? So there are two methods to find the prime factorization. One is division method. Another one is factor tree method. Suppose if you have a number, like 16, you can in factor tree method you can represent as a prime factor. 16 can be written as when you multiply two numbers, you will get 16. What are the two numbers? You know. So 2 and 8. If you multiply 2 and 8, you will get 16. Okay. Again, you can try to reduce it. It can be reduced 2 as a product of two numbers. No. Okay. You will end up with 1 into 2 only. So I am going to move with this number. So can we write as a product of two numbers? Yes, 2 into 4 you can write. Okay, so again, can you write 2 as a product of two numbers? No. So anyway you will get 1 into 2, which is the same number, so I'm not going to bother about that. Can we write 4 as a product? Yes, we can write 2 into 2. So you can know that this is the final number in this branch. This is the final number in this branch. So these two are final numbers in this branch. So 16 can be written as 2 into 2 into 2 into 2. Okay. Okay. Can we see any other example? What about 90? 90 can we write as a product of two numbers? Yes, 2 into 45 is 90. Okay, so 45 can be write as a product of two numbers? Yes, 2 you can't write, remember that 2 you can't write. 3 into 15 will give you 45, isn't it? So you can write 45 as 3 into 15. Then this 3 you can't write as a product of prime numbers, so I'm going to write this 15 as a product of prime numbers. So 3 into 5, 3 into 5. Okay, so you can write 3 into 5, which is 15. Again, can you write as a product of prime numbers? No. Product of any two numbers? No. So what I'm going to do is I'm going to round these numbers. I'm going to round these numbers. These numbers are you can write 90 as 2 into 3 into 3 into 5, isn't it? Yes, this is called prime factorization. Do you have any other number? You have only prime numbers. You don't have any number other than prime numbers. So 2 is a prime number, 3 is a prime number, 5 is a prime number. So we can write any number like 90 and 16 as a product of prime numbers. This method is called factor tree method. In this method, what do we find? We find prime factorization. So how will you find the prime product of prime numbers? Using division method. Using division method. So the same 16 I am going to take. Okay, I will start with the smallest prime number. What is the smallest prime number? 2. So I am going to divide by 2 now. So we'll get 8. Okay, then again you have to again try to divide by the same smallest prime number. I'm going to divide again by 2. Is that possible to divide by 2? Yes, so we can divide them. So you'll get 4. Then again you start with the smallest prime number. Okay, if you can't divide the smallest prime number, you can move to the next prime number 3. But here we can divide by 2. So you'll get you'll get 2 here. Again, if you divide by 2, you'll get 1 here. So 16 can be written as 2 into 2 into 2 into 2. Okay, then both factor tree method and division method gives you the same prime factorization. So you can use any one from these. Okay, so 90 also, can we try the same thing with 90? So I am going to divide by the smallest prime number. What is the smallest prime number? 2. You will get 45. If you divide again, can we divide again by 2? No, it's not possible. So you try with 3. How many 3s are there in 45? 15. Again you try with 3, because you have to keep on divide by the prime number. Then if you can't divide, you have to move to the next prime number. Okay, then here you can get 5. So can we divide again by 3? No, it's not possible. So I'm going to use the another next prime number. After 3 you have 5, so I'm going to divide by 5 now. So you will get 1. Okay, so you will get 1. So how will you write 90 now? How will you write 90? You can write 90 as 2 into 3 into 3 into 5. So this is the prime factorization. This is very important to find the LCM or GCD of any two numbers or more than two numbers. Okay, so how will you find LCM now? LCM of two numbers. We know how to find the least common multiples of any two numbers. Okay, let's say I want to find the least common multiples of 2 and 3. Okay, so we have to write the multiples of 2 now. We have to write the multiples of 2. What are the multiples of 2? 2, 4, 6, 8, 10, goes on, no? So I'm going to write the multiples of 3. So 3, 6, 9, 12, and it goes on. So what are the common multiples here? Do you have 3 here? No. Do you have 4 or 3 here? No. 6 you have, and if you write the next number, you will be having 12. So 12 also there. So these two are common multiples of 2 and 3. But among the common multiples, what is the least one? Least one is lowest one, that is the smallest one. So 6 is the least common multiples of 2 and 3. So what is the least common multiples of 2 and 3? It is 6. Okay, so this is the common method to find the least common multiples. But when you have a bigger number, can we find the multiples of that bigger number easily? No, it takes time. So what do you do? So what do? You can use another prime factorization method. It's very easy. Okay, so it's very easy, so I'm going to teach you that. So LCM using prime factorization. How will you find LCM using prime factorization? Suppose if you have two numbers, let's take 25, 40. So you have to find the LCM of these two numbers using prime factorization. So what you do here, you find prime factorization of 25 and 40. Okay, you can find the prime factorization using factor tree method or this division method. So let's use factor tree method here, because you should know what are the prime numbers. So we know that 2, 3, 5, 7, these numbers are prime numbers. So we have to start with the smallest prime number. No, so you try to divide by smallest prime number. Is that possible to divide 25 by 2? No. So again with 3, is it possible to divide by 3? No. You will get remainder. So you cannot divide with these two. But can we divide by 5? Yes. So how many 5s are there in 25? 5 5s are there. Again you try with 5. Can we divide by 5? Yes. how many 5s are there in 5? 1. So 25 can be written as 5 into 5. Okay, 40 you try with the smallest prime number. Can we divide with the smallest prime number? Yes, 2. Then again with the smallest prime, you will get 20. Then again with the smallest prime number, so 2, 10 you will get it. Again with the smallest prime number, you will get 5. So can we divide by 2 again? No. Can we divide by 3? No. You will get 2 as a remainder. Can we divide with 5? Yes, we can find. We can divide the 5 with 5. So when we divide, you will get 1. So how can you write 40? 40 you can write 2 into 2 into 2 into 5. Okay. So what is the common here? What are the common factors here? Only 5. Sorry for that. So I'm going to circle the common. So this 5 with this 5 is common. Any other common factors? No. So you group these two, you write as a 5. We are going to find the LCM. No. So you group, you multiply all other numbers. This 5 I wrote here, and these 2 I am going to write here, and these 2 I am going to write here, and these 2 I am going to write here. So I grouped these 2 common factors and wrote as 1. The remaining factors I wrote like this. I didn't reduce it further, so I wrote it like this. So how will you find? 2 into 2 is 4. 4 into 2 is 6. 6 into 5 is 5 6 are 30. 30 into 5. Okay, it would be 150. So what is the least common multiples of 25 and 40? This is 150 is the answer. So least common multiples of 25, 40 is 150. Okay, can we do the other sum when we have 3 numbers? Let's say we have a 3 number, 39, 45 and 54. Okay, 54. So using prime factorization, we are going to find the LCM. So we are going to find the LCM using this prime factorization method. Prime factorization method. Okay. So I'm going to write 39 now. So we know what are the prime numbers. Prime numbers are 2, 2, 3, 5, 7 and it goes on. So 39. Can we divide by 2? Is that possible? No. Can we divide by 3? Yes, we can divide. So 13 3s are 39. Again, can we divide by 3? No. You cannot divide with any other prime numbers except 13, because 13 is the prime number. So 39 can be written as 3 into 13, isn't it? And 45, what about 45? Can we divide by 2? No, it's not possible. Can we divide by 3? Yes. So you'll be having 15. Okay, I'm going to divide again by 3. You'll get how many 3s are there in 15? 5. Can we divide by 3 again? No. So we move to the next prime number, 5. Okay, so how many 5s are there in 5? 1. So 45 can be written as 3 into 3 into 5. What about 54? 54. How can we write 54 as a prime factorization? So can we start with 2? Yes. You have 27 2's in 54. Can we divide again with 2? No. So 3 we can divide by 3, you will get 9. Again by 3 you will get 3. Again by 3 you will get 1. So 54 can be written as 2 into 3 into 3 into 3. So here you can see what is the common common factors here. You have 3 here, 3 here and 3 here. So you circle that now. Do you have any other 3 here? No. Do you have 5 here? No. Do you have 3 here? No. Okay. So but you have 3 and 3 here. You circle that also. Not only the common between all the 3 numbers, when you have a common between any 2 numbers also, you circle that. That is the difference between GCD and LCM. Okay. So how will you find the LCM of 39, 45 and 54? Okay. How will you find? Do one thing. You group these 3 as 1. You write these 3 as 1. Okay. Okay. Then again you group these 3 as 1. So into 3, and remaining numbers you write as it is. 2 into 3 into 5 into 13. So this is the least common multiples of these 3 numbers. 3 into 3 is 6. 2 into 3 is let me write 3 into 3 is 9. 9 into 2 is 18. 18 into 3. I think we need calculator. Okay. We need calculator. So I'm using my mobile to calculate 18 into 3. 54. 54 into 5. 270. 270 into 13 will give you 3510 is the answer. In this way we can find the LCM of 3 numbers. So this is the procedure. Thank you.